Good morning, guys. Today we're going to go over 9.3, the last class of the year. And pretty much what we're going to learn here is how to work with circles, unit circles, and a couple of other things. How to find angles and the so-called reference angle. Now, first of all, we were working with triangles that were just independent. You know, this is a right triangle. Please find the sine of this angle. Or this is a right triangle. Please find the sine of this angle. And you know, you use SOHCAHTOA. Should remember that. Now today, all we're gonna do is put these triangles inside a circle using a coordinate axis. Now note, this triangle is always formed in the following fashion. You always go from the origin to the circle and to the x-axis. You never form a triangle with the y-axis. You never form a triangle with the y-axis. We always go from the center to the circumference or the circle, and then to the x-axis. Always. There will never be a situation in which you do a triangle with the y. Never. It's always with the x. Looks like a little face, but bueno. Now let's let's look at this particular triangle. Now, also, there's another thing. When the triangles were independent, we could have used this angle, we could have used this angle. You know, the angle changes. Here, you will always use the same angle, and that is the angle formed from the terminal side, which is the side that moves, and again, the x-axis. That is always going to be the angle. Doesn't matter where it points. Say, for example, if I have this triangle, this would be the angle. Again, terminal side and the x-axis. If it is upside down, this would be the terminal side and the x-axis. So again, regardless of which angles, of how the angle, you know, what quadrant the angle ends up in, we always use the angle between the terminal side and the x-axis. Boom. The terminal side and the x-axis. The terminal side and the x-axis. The terminal side and the x-axis. And note, all these triangles are formed using the x-axis as well. None of them are formed using the y-axis. Now, why do we work in this fashion? Just to make things easier. You'll see, it's gonna make a whole lot of sense now. Now, let's say this is, well, let's not say that is your x-axis, that is your y-axis. Let's say I am working with this particular triangle. I know that this is going to be the angle I'm going to use as a reference point. Again, it's not the same thing as a reference angle. You'll see what that is later. But I'm using this angle. Now, let's try to find all my trigonometric functions using that particular angle. If I were to use sine of this angle, sine would be opposite divided by hypotenuse. Yes or no? So when we look at the picture, the opposite value is actually the y value of the coordinate. So if I were to get, let's say this coordinate is 4, 3, would that y portion not be the y portion of the coordinate? Yeah, so pretty much the opposite side is the exact same thing as y. The opposite side is always going to be the exact same thing as the y value. Doesn't matter what quadrant I end up at. If I use this angle, which is the one you should use, because again, you always use the angle that's at the origin, the opposite side of this angle will be the y value, going up or down. The opposite side of this angle will be the y value the opposite side of this angle will be the y value. So I know that every single time, the opposite will be the exact same thing as the y value. And you'll see why it's going to help you a lot when you look at the unit circle. Now let's look at cosine. Okay, opposite is, sine is opposite over hypotenuse. And the hypotenuse, would that not be the radius of the circle? The point going from the center of the circle to the circumference. That's the radius of the circle. Again, radius. So the hypotenuse of this triangle is also the exact same thing as the radius of the circle. So saying opposite over hypotenuse is the exact same thing as saying the y value divided by the radius. That's going to help you in two ways later on. Now let's go over the next one. Let's go over cosine. Cosine is the same thing as adjacent over hypotenuse. And if you look at this triangle in the first quadrant, the adjacent side would be this side. And is that side not the x value of that particular coordinate? If I give you this coordinate, again, 4, 3, would this portion not be the x part, or 4? Yeah, so adjacent is the exact same thing as x. And hypotenuse would again be the radius of the circle. And tangent would be opposite over adjacent. Now you know that the opposite is always the y value, and the adjacent is always the x. So tangent would be the exact same thing as y over x. So if I tell you, find the tangent formed by a triangle circumscribed in a circle using this coordinate as this point, is this point 4, 3, then the ratio of tangent would pretty much be y over x. Y over x. We're actually going to do, that's example 2. We're going to do example 2 now. And note, again, these values are in the book on page 478, but they're very clear. Opposite will always be y, always. Adjacent will always be x. And the radius, the hypotenuse will always be the radius. That's example 1 in the book. Now let's go over example 2, which is what I was just doing, like finding some examples. Now, okay, in the book, they're actually using -4, 3. So let's draw that particular triangle. Let's draw that particular triangle inside. Okay, let's just do this. It's going to be easier. So let's say I have my coordinate and I use this point, -4, 3. It should be here, more or less. I draw my triangle beginning at the origin, going to the circumference, then down to my x-axis, and I always use this angle, the angle formed with the terminal side and the x-axis. That's stuck to the origin. Now I know that this side is -4. Oh, sorry, mistake. X is the adjacent. I know this side is -4. And I know this side is 3. How do I find the radius of that circle? Easy. The triangle formed here will always be a right angle. So we use Pythagorean theorem to find the radius of that circle, which would again be the exact same thing as the hypotenuse of the triangle I am forming. So a squared plus b squared equals c squared. A squared is -4 squared, or 16, -4 times -4. B squared is 3 squared, or 9. 3 times 3 will be equal to c squared. I add these two, gives me 25 is equal to c squared. I isolate my c by doing a square root. I end up with 5. Okay, even though the answer is positive -5, the hypotenuse is always the positive value, or 5. Hypotenuse will never be negative. Okay, now that I have my three values. Let's see. Sine is opposite over hypotenuse. I know that my opposite is my y value, or 3, and my hypotenuse is 5. Cosine is adjacent over hypotenuse, -4 over 5. And tangent is opposite over adjacent, or y divided by x. Those are only 3. Now we go over the inverse. The inverse of tangent is cotangent, and all I do is reciprocate these. I flip them. The inverse of cosine, remember, sine, secant. The inverse of cosine is secant, so secant would be the reciprocal of this, 5 over -4. And the inverse of sine, is cosecant. Cosecant will be equal to 5 over 3. Those are pretty much the values that you're going to be using. If I tell you, if you go over example 1, evaluate the 6 trigonometric functions of the angle formed using this. Okay, so that's pretty much example 1. Now let's go over a very important subject you will be using a lot next year. If you're going to be with me, you're going to be using the unit circle a ton. So make sure you get this right. And again, it's pretty much going to be an intro to the unit circle. A unit circle is pretty much a circle with its center right on the origin and also a radius of 1. So this circle has a radius of 1 and its center is right on the origin. That's what's called the unit circle. Now, we don't use the circle formula a lot so far, but you will be using it plenty. And the unit circle has that particular formula, x squared plus y squared. Here you should have a, I actually can't remember. But this is the formula for, that's how much we use it. I can't remember myself. But this is the formula for the unit circle, okay? And if you think about it, well, yeah, you know, this could be squared, but it's 1 because 1 squared is just 1. If you think about it, let's see why this is. If I were to draw my triangle here, would this not be one side? And would this not be the other side? And if this triangle is a right triangle, would Pythagorean theorem not be one side squared plus the other side squared equals my radius, or c squared? A squared plus b squared equals c squared. Since c, which is the hypotenuse, is 1, and 1 squared is 1, that is the formula for the unit circle. Now, honestly, you don't have to know this formula right now. The important thing that you have to know about the unit circle right now is that the radius is 1. And you'll see why this is important. When we look at sine now, and you know that sine is opposite over hypotenuse. If the hypotenuse is 1, what is any number, this is opposite, any number, opposite, not 0. What is any number divided by 1? Well, it's the original number. So again, if you're working with a unit circle, and it has to be very specific, unit circle. If it is a different circle, you would use opposite over hypotenuse. If you're working with a unit circle, since you know the hypotenuse is 1, using a unit circle, you can say that sine is the same thing as just the opposite side, or y. So sine equals y. Again, let's go over an example. If the radius here is, if this is 1, again, let's say this value is, well, let's not give actual values because it's not going to mathematically make sense. But just know that this value divided by 1 will be this value, or y. And at the same time, cosine is adjacent over hypotenuse. If my hypotenuse is 1, I'm saying that cosine equals just adjacent or my x value. Okay, let's see if I can find an example here. No, not really. There isn't an actual example. Okay, well, that's just a theoretical concept. You have to know that sine of a unit circle is the exact same, when an angle formed with a unit circle is the exact same thing as just the y value, because y divided by 1 is y, and cosine is just x, because x divided by 1 is just x. Now, tangent would be the exact same thing, y over x. Now the inverse do change, because the inverse would pretty much be 1 over the value. It's the exact same thing. You just flip it, flip it, flip it, and you would be done. So that's pretty much the theoretical part you need to know about the unit circle so far. That's it. Sine equals y, cosine equals x, tangent equals y over x. Now there are some things called quadrantal angles. Quadrantal angles. Say, for example, I have this circle and my angle ends up right there, or my angle ends up right there, or I have an angle that ends here, or, you know, any angle that falls directly on the terminal side, which falls directly on the x or y, will be what's called a quadrantal angle. Now, let's see what happens with certain quadrantal angles. Let's say I'm working with the unit circle. Let's say I'm working with the unit circle. And I have a 90-degree angle. 90 degrees. When we use radians, remember, since the entire circle is 2 pi radians, half a circle would be pi radians. A quarter of a circle would be pi over 2 radians. Let's see what happens. If I'm working with a unit circle, I know that my hypotenuse would be 1. So the y value is 1. But in this point, if you focus on the x and y axis, what is the x value of this point? The x value at this point would be 0. So in a 90-degree angle, my y equals 1 and my x equals 0. Again, let me show it in a bigger fashion. If I'm using this angle, just to make sure it's perfectly clear, if I'm using this angle and this point, if you were to trace that point on the x or y axis, the x here would be 0 and the y in this case would be 1, because the radius of the triangle formed here is 1. Now, if I were to use my identities with these values, let's see what happens. I know that my y is 1 and my x is 0. And I also know that my the radius is always going to be 1 because it's the unit circle. Let's go over sine. Sine is opposite, or y, over hypotenuse, which is 1. Or, as I said, since it's a unit circle, sine is the same thing as y. So sine would be 1. Cosine would be the exact same thing as x. Cosine would be 0. Now, where it's tricky is when we're dividing. For example, tangent is y over x. And what is 1 divided by 0? 0, profe. Obviously. No, remember, 0 divided by 1 is 0. 1 divided by 0 is not a number. Profe, the calculator is giving me an error. That's why it doesn't exist. It's not a number. Not a number. So, tangent of 90 degrees, if you plug that into your calculator, you're going to get an error message back because it doesn't exist. Don't freak out. Okay, you're absolutely correct. Tangent of 90 degrees is not a number because when I divide y by x, I get something that isn't a number. However, cotangent does exist because it's 0 over 1 or 0. If you plug that into your calculator, you will get an actual value back. And that works for pretty much all angles. Let's try a 180-degree triangle now. A 180-degree triangle. So instead of the point being here, it would end up being here. I have a negative x, and a y of 0. Since this is negative, I know that my x, since that's the radius of 1, because I'm working on a unit circle, I know that my x is -1, and my y value is 0. It has not gone up or down. So y value is 0, and my x value is -1. If I go to my sine function, boom, no problem. Sine is my y value, or 0. If I go to my cosine value, -1. It's the same thing as x. If I go to tangent, it's y over x. Now here my tangent exists, but let's go over the inverse. Cotangent of 180 would not exist because it's 1 over 0. Now, even though I did not put the hypotenuse here, let's put it and let's see what happens. I know my hypotenuse here is 1, and I know that my hypotenuse here is 1. So sine of 180 degrees is still 0, because 0 over 1 is 0, and that exists. Cosine would still be -1. Because -1 over 1 is still -1. But what happens when I do the inverse? I know that cosecant would be 1 over 0, not a number. Cosecant of 180 degrees does not exist. Secant would still be -1, because 1 divided by -1, the inverse, would still be -1. So here you can play around with different angles, and again, these are just quadrantal angles. Angles that fall exactly on the x or y, which means that if it falls on the x, the y will be 0. If it falls on the y, the x will be 0. Those are quadrantal angles. You can play around with them and see which ones exist, which ones don't. Again, the focus for the end of this school year won't be that, that heavy on this, but note that you will be using this a ton next year, a ton. Okay. Again, you use the unit circle a lot next year, trust me. Now, one other thing. Evaluating the trigonometric functions. And again, this is just for the positives and negatives. In the first quadrant, the x is positive and the y is positive. In the second quadrant, so say my value ends up here, my y is still, it's always going to be positive, but now my x is negative. In the third quadrant, say I end up here, both my x and my y will be negative. And in the fourth quadrant, say here, my x is positive and my y is negative. Now, why is this important? Because you will see sometimes, again, not so much this year, but next year you're going to be working a lot with this. So, for example, if I tell you, how is the sine value in the second quadrant? Is it positive or negative? You know that the sine is equal to y. Again, sine is equal to y in a unit circle, and you can use this with a unit circle. In the second quadrant, how is my y value? Positive. So sine in the second quadrant will be positive. How is sine in the third quadrant? Negative. Again, because my y is negative in the third quadrant. My y is negative in the third quadrant, so my y would be negative. Some students look at the table on page 480 that has all these values here, and they say, Prof, I'm going to memorize those values. Do not memorize those values. You're going to forget them in a day, and you'll not learn anything. And besides, believe me, you'll spend more time memorizing that little table than just using this. Again, miren que fácil. You draw an x and a y axis, positive x, positive y, negative y. And you know that your sine is y, your cosine is x, and your tangent equals y over x. If I tell you tangent of the fourth quadrant, you put a period there. How is my x here? Well, no, my x is positive. So you substitute this for a positive sign. How is my y? Well, no, my y is negative. And what is negative divided by positive? You get a negative answer. So tangent here would be negative. What is cosine here? Cosine is just x. How is my x in this quadrant? My x is negative. So cosine in the second quadrant would be negative. How is my tangent in the first quadrant? Well, no, tangent is y over x. My x is positive, my y is positive. So positive divided by positive would be positive. It's way easier to understand this little diagram and put the point and then just see where your x's and your y's are positive or negative and learn these three things, which you do need to learn for next year and, you know, SATs and whatever. So you do have to learn this. But don't memorize the table on 480. That's very impractical and it's, I'm not going to say stupid, it's just not effective, not efficient, and you're just memorizing instead of understanding why those values are positive or negative. You're going to say, again, believe me, students say, no, profe, I'm going to learn that little table. Happened before. And the next day they come and they say, no, you know what? Okay, let's go over the diagram again, please. That table is just, do not memorize the table. Know how they work. Positive, positive, negative, negative. What quadrant falls where? Again, just in case, this is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. They go clockwise, counterclockwise. Math teacher here. They go counterclockwise. So again, learn this diagram. You do need to learn that diagram. In the exam, I'm probably going to ask you, tangent, third quadrant, not quadrant. Got school in my brain. Tangent, negative over negative. Tangent here in the third quadrant will be positive. There's no need to memorize an entire table full of wacky values when you can understand what's happening in this very simple diagram. Okay. And the last thing we're gonna go over today is what's called the reference angle. Again, we're not really gonna use them this school year, because again, this is the last class, but next year you're gonna be using reference angles plenty. And we're going to go over them as well. Now, a reference angle is pretty much, the definition is on page, let me find it, on page 480 at the top. And it says that a reference angle is an acute angle formed with the terminal side and the x-axis. Remember, acute means greater than 0 and less than 90. Now, why is this important? Because, say for example, if I have an angle that ends here, instead of, let's say this angle is 220 or something. Let's say that angle is 220. Instead of using this huge angle, 220, you can find the reference angle, which is the acute angle, or this, which is a smaller number, and you can use that angle to represent this entire angle. And I'm going to show you how to find that reference angle. It changes depending on what quadrant the angle lies in. Let's say, for example, I have this, again, I do have to draw a circle. Let's say I have this circle, and I have this angle. that angle is already in the first quadrant, and that angle, by definition, since it doesn't fall on the y-axis, is an acute angle. That angle is less than 90 degrees, so what's in the first quadrant, no change needs to be done. No change needs to happen. Nothing needs to happen there, you use that angle. Now let's use a bigger angle. Let's say that this angle is 120 degrees. For the people who are smart and already got this, you know that if this angle is 120 degrees and a semicircle or half a circle is 180 degrees, then the reference angle should be 60 degrees. So the formula is, when the angle falls on the second quadrant, it is 180 degrees minus the angle, the original angle. That's going to give you the reference angle. 180 minus 120 is 60 degrees. So no matter where that angle falls on the second quadrant, it's always going to be 180 minus the angle. Again, let's draw it again. If I have this angle here, this angle, the reference angle, again, the reference angle makes us fall within the triangle. That's why we need it. And we're not going to go heavy into that. That's the whole point. Instead of using this obtuse triangle, I would use the reference angle that forms a right triangle. And that angle falls inside the triangle. If this angle is 170, this one would be 10 degrees, because together they make up 180. So second quadrant, no matter where it falls, 180 minus the original angle will give you the reference angle. Let me write this formula here so you can just see it. That means theta. It's like a variable angle, pretty much, okay? Now let's see what happens when the terminal side falls on the third quadrant, which is similar to here, and some students get confused. Let's say I have a 200. Oh my God, that's very not good. Let's say I have a 200. Let me do that again. And this shows us why we use reference angles. Let's say this angle, again, I began here and I ended here, is actually 200 degrees. This angle, which is the one I should use for my identities, that angle itself is not 220 degrees. It's way smaller. We find the reference angle for this angle, and it's going to give you the exact same value that you should be using. Now, when it's in the third quadrant, you can see that it has slightly gone over 180 degrees. This is 180 degrees, and I've gone slightly beyond that. It is a very similar formula. If the entire angle is 200 degrees, and from here to here, I know I have 180, then this part has to be what's missing, or 20 degrees. So the formula, when the angle is in the third quadrant, is similar to this, but flipped. It's actually the original angle minus 180 degrees will give you the reference angle. 200 minus 180 will give you 20 degrees, which is what you should be using. Third quadrant. Let's see, 180, this should be 270. If I tell you the angle is 260, again, third quadrant, it's going to be the original angle minus 180 degrees will give you, oh my God, I'm so stupid, 80. I take 100 off. Yeah, 80. I'm left with 160 minus 80 is 80 degrees. I apologize. I'm just not very mentally sharp these days, thanks to being stuck at home forever. So 80 degrees. The angle, the reference angle for a 260 degree angle would actually be 80 degrees. And whenever we're working with right triangle trigonometry, we'll be using 80 degrees here instead of 260 degrees. Now, let's see. So we know that the formula for the third quadrant is the angle minus 180 degrees. For the smart folks, you should already know how to work the fourth quadrant. The fourth quadrant. Pretty much, the fourth quadrant, if I have this angle, the reference angle is what's missing to complete an entire circle. So let's say, for example, I have 300 degrees. The entire circle is 360 degrees. So pretty much the formula is 360 degrees minus the angle will give you the reference angle. 360 degrees minus 300 will give you 60 degrees. Again, those formulas never change. So depending on where the angle falls, and of course, the first quadrant, no change. That is the reference angle. You need to know how to work with reference angles. They will show up in the test. If I tell you find the reference angle of a 320 degree angle, you have to tell me, okay, 320 degrees. 320 degrees falls in the fourth quadrant. So the angle would be 360 minus 320 degrees. The reference angle would be 40 degrees. That's it for today's class. If you have any questions, let me know. Note, the exam for what we've seen in Chapter 9, which is Chapter 9.1, 9.2, and 9.3, will be on Monday. That's the last test. I will be uploading the homework grades this weekend. Every week will have its own grade. Every week will have its own grade. If you're missing any homeworks, turn them in today. Because if I check that week for homeworks, I am not changing the grade again. Repito, if you have any late homeworks, turn them in today. Because I'm going to be checking week per week who's missing homeworks. And once I put that grade, I am not giving you a second chance to upload any work. The chance that you have is today and all the time I've given you beforehand to upload late homework. If you have any questions about your grades or homeworks, I'm still uploading them. The Chapter 5 test will be modified to increase the value because one of the questions was actually canceled. So you can wait on that. And overall, the tests are worth less compared to the weekly work and the project. Finally, for tomorrow, I need to know, you have to send, I'm going to send that homework tomorrow. You need to send me the filled in template with the description of what you will be doing. Next week, I will have a call with every single group. It has to be done. Every single group will form a call with me at some particular time so we can discuss the project and how it's going. So make sure you fill in the template for tomorrow. I am going to do a post for that tomorrow, reminding you guys. And for today, please do the following homework. Please do the following homework. Please do number 4, which is example 1. Number 9, 10, and 11, which is quadrantal angles. And then do 15, 16, 15, 16, 17, 18. For these 4, you do have to do a rough sketch of the angle and then find the reference angle. That's it for today's homework. Send it in before 11. And before I finish, I want to do a very, very special shout out. right at the end of the video. I hope everybody sees this shout out. This shout out goes to Paulie and to Claudine. Thank you for taking the time to do the awesome intro we saw at the beginning of the class. I loved it. Very funny, very upbeat to start the video. And I appreciate the interest you have shown with my class. Now, unfortunately, I was only able to use that intro once this year for today's class, but I will be using it every single day for next year, because I believe that next year I'm going to do the exact same system. Whether you are at home or we are in class every day or half and half or whatever, I'm going to do a video every day, which you can see as many times as you need at home, and then we can work the other day in class. So that awesome presentation of Mr. Bernal's class will be used every day next year. So I really appreciate the work. So again, shout out to Paulie and Claudine. You rock. Take care, guys.